In this video we will do some experiment in which we will try to figure out how we can draw some basic signals, and all the signals will be of type discrete. We are not going to draw any signal that is continuous. We will sketch discrete signals in Matlab. So before sketching that signals in Matlab, we must have understanding of some basic functions that will be used inside the Matlab code. So the first function is used as to create numbers, and it is created by a symbol colon. So for example, I write a code here. Let's say n equal to -10 colon 10. What this code will do? When we will run this code will create 21 points. 21 points, and the points will start from -10, -9 up to -2, -1, 0, 1, 2 up to 9 and lastly 10. So we have here this one 11 points including 0, and here we have 10 points. So all together we have 21 points. So by this code we can create different points in Matlab. We will see this in command window. So let's go to the Matlab online and we will run this code. I have to write here, this is our command window. We can say this is our command window. Here this sign is elaborating that it is a command window, and in this we will write the code. We have to write the code as n equal to -10 colon 10, and we will see the output. Suppose I write at the end colon, then we will not get the output. Still the number n has been loaded to the workspace. We can see here it is the 1 cross 21, means it is a matrix having 1 row and 21 columns. That's why it has written 1 cross 21. Suppose now I want to see the value of inside n, so I will write n and we will hit enter. So now we can see here we have the all 21 points showing in the command window. So we have to understand what is the meaning of this line -10 to 10 having n like this. So this is our first function. We can create any number of points by this function. Suppose we want to write other value, let's say x, and we will say we have to consider points from -3 to 2 means colon 5, and we will hit enter. Since we have not used semicolon at the end, so we are getting the values directly from -3 to 5. So in this way we have understand our first function. Now we will go to the second function, which is necessary for creating the program at the end. So let's go to the board, and here the next function is called zeros. Zeros is a function which takes two input. Zeros, zeros, it is a function, it takes two input. What does this function does? Its work is to give vectors or matrix of zeros. It will create matrix of zeros, and we know that matrix have what? Columns like this and rows like this. So we have to specify here what number of rows and then column. So this will create our matrix by writing just this. Suppose now I write here zeros 3, 4, means we want to create a matrix having 3 rows and 4 columns, and all the points inside that matrix will be 0. So I will write like this. We have to create 3 rows, first row, second row, third row, and 4 columns, first, second, third and 4, and all will be filled by zeros. All will be filled by zeros. This was our function of this matrix. In the similar way we have ones. Here also we can create 3, 4 and it will also create same matrix but same size matrix, but the values will be replaced by ones. Now this will not be zeros, but what we will get? 1. We will get instead 1. All the values are now ones. So if we write zeros, then we will get zeros matrix, and if we write ones, then we will get ones matrix. Now if we want to create vector, 0 vector, then for that vector can be two types. One can be row vector or column vector. Suppose we want to create a row vector. Row vector will have only one row. So let's do here. We want to create zeros having one row and 7 columns. So what will it give? It will give 0, 0, 0, 0. How many zeros? It will give 7 zeros. 3, 3, 6 and 1, 7. So it has given 7 zeros, and it has one row and 7 columns, and all the points are filled with zeros because we have written zeros here. We can do the similar things in Matlab also. Here we will do the, let's call a variable name y. It will be our 0 matrix, and let's type here ones. Suppose we want to create zeros first, then we will type zeros. So zeros, and in between we suppose we want to create the same 3, 4, यानी कि 3 row and 4 columns. We can see here we have all the 3 rows and 4 columns, and all are filled with zeros. We can create the similar things, just we will what here write ones, and now we have ones. Y has been replaced by this y, and we have ones. Now suppose we want to create one vector, column vector, not the row vector. So what I will write? I will write z. In variable z I will want to create one column vector, and column vector having all zeros, then zeros zeros. It will have 6 rows and 1 column. So we can see its type. Here is it. We have 6 rows and 1 column, and all are filled with zeros. So it is zeros, and we have ones similarly. In this way we have completed all the functions which we will know in the program. So now let's write the program on board first, and then we will go to the Matlab. So let's write one program. N equal to -5 to 5. We understand this meaning. And now x equal to zeros 1, 5, ones 1, 1, zeros 1, 5. So what it will do? We know the values inside n. What will be the values inside n? N will start from -2, -4, -3 up to 1, 2, 3, 4, 5. But what will be values inside this x variable? So x will contain zeros of 5 columns. So 1, 2, 3, 4, 5, and then 1 of 1 column and 1 row. Similarly 1 row we have 1, and then again zeros of 5 column. So this will be our x vector. After x we have used the next command, which is subplot. Means we have to plot these values. We have the n values which will be plotted on x axis, and this x will be plotted along y axis. So this is the values, and this is the discrete time variable. And we will use the subplot command. For we have divided the figure window into 8 parts. In that 8 parts we are using the first part. This means 2, 4. 2, 4 means what? We will divide a paper into 2 columns. I will say 2, 1 minute. So here we will have 2 rows and 4 columns. So I will divide it, I will sketch like this. We have 2 rows and 4 columns like this. So in total we have divided the figure window in 8 parts. So 1, 2, 3, 4, 5, 6 and that 7, 8. We have divided the figure window in 8 parts. We are using the first part to show this plot. So this is the first part. In the next we will write the next program in the second part. In the third part similarly we will use subplot 2 comma 4 comma 2 2 comma 4 comma 3 up to, we can use up to 2 comma 4 comma 8. This will be the our last. So in the first program we are using 2 comma 4 comma 1 only, and after that we will write our function which will plot actually. So stem is the function which plots n with respect to x, which plots x, which plots this x with respect to n, means n is along this side and x is along this side. So we are going to get our function like this. We are seeing here n is going from minus 5 to 5. So minus 5, minus 4, minus 3, minus 2, minus 1 and then 0, then 1, 2, 3, 4 and 5, and the values are 0 0, all time 0, here it is the values, and at 0 we are getting 1, at 0 we are getting 1 and again we are getting 0 0 up to 5. So which kind of signal is this? This is the impulse signal. This is the impulse signal. In this way we have created our impulse signal with this code. Now we will label our axis. So x label, it is used to give label to the x axis, and then y label, it gives label to the y axis. And then at the end we will give our title. Title is unit impulse. So in this way our code is completed. So now we will write this code in Matlab itself online. For that what we will do, first of all we will clear this. So we can use the command clear all. It will clear the workspace which we have created here. In the workspace we can see there are several variables. By this command we will clear all the variables. We can see the variables has been cleared, and now to clear the command window we will use CLC. So now we can see the Matlab is clear and again new, and so we will create one folder here. New, we have to create folder. The folder name will be digital signal processing. Now inside this folder we will create our code. So to create the code, first of all we will create a file, .m file, in which we will write all the code. To create the file we will write the code, edit, and let's name the file as different signal, DIFFSIGNAL. So it is our file name, and now we will hit enter. Editor window will open now. Now as we can see, command window has gone down, and this is our editor window. For now it is empty, and in this we can write our code. So we will write n equal to -5 to 5. After that we will comment that we are going to create a unit impulse function. Unit impulse function. unit impulse function. So inside this we will write all the codes. X is ranging. Inside x we have to write the values which we have to create. So it will be 1 comma 5, and after that we have again comma ones. So we have to write ones. 1 is 1 comma 1, and again we have to write zeros, and its values is again 1 comma 5. After that we have to use the subplot. In that we have to create 2 comma 4 subplot, and we will be using the first plot here, and then stem is the function which is plotting actually, and after that x level. After that x level we are labeling the x as n, and now y level we are labeling y as x of n, and at the end we will write our title. Unit impulse. So in this way we have created our first signal. Now we will check it by running it. So let's run this. Here is the run button. We will run it. If all codes are right, then it will show the figure. So this is the figure window has been appeared. Let's hope for the figure. So as we can see now, the impulse function has been created. This is our impulse function. In the similar way, we can write the code down to create other functions. So let's go down, and we will now create our next signal. The next signal is unit step signal. Unit step, either we can write function, that has not much difference. X is going from, we are getting the values of x in here we have the x we have seen earlier. This is 0 0 up to n equal to 0, and at n equal to 0 we have 1, and after n equal to 0 again we have the value as 0. But in case of unit step we will have 0 up to 0, and after 0 we will get 1. So for that we will write zeros. So zeros, so we will have to put zeros up to, we have to put zeros up to 5 points, and after 5 points, that is from 0 we have to put 1. Okay, so this will create ones, but we have to write here ones, otherwise it will not create. So we have the ones from 1 to 1 comma 6, that is it will create after zeros, n equal to 0 it will create 1, and here is, I will elaborate this, and after that we have nothing, that's we have to write all the same thing. So I will just copy it and I will paste it here like this, and here I will write unit step signal. So I will write here unit step, that's all. And now we have to change the plot, it will be 2 because we have used the 1, so it will be 2. Now let's understand this line of code, what it is saying. For that we will go to the here and we will write here, just like before we have here 0 zeros. In the similar way we have written the code like x equal to zeros 1 comma 5 and then comma ones 1 comma 6 like this. So this zeros will create 0 vector of 1 row and 5 columns. It means it will create 5 zeros in a row like this, and after that it will create 6 ones in a row. So 1, 2, not 2, 2, 3, 4, 5 and 6. So 6 ones and 5 zeros. This zeros is standing at n equal to minus 5. This 0 is standing at n equal to minus 1. This 1 is standing at n equal to 0 and this one is standing at n equal to, what we can say, n equal to 5. If we want to plot it, again we can plot it. Here it will be n and here it will be x of n. Now 5 point here, 1, 2, 3, 4, 5. So minus 5, minus 4, minus 3, minus 2, minus 1. Here it is 0, 1, 2, 3, 4 and 5. And then we will write the values. So it is 0, 0 up to minus 1 and after 0 n equal to 1. At n equal to 0 to n equal to 5 we have the values as 1s. So I will draw like this. So it is a discrete time step signal. It is nothing but discrete time step signal. So this signal is created by this function. So in the Matlab also we can see it. We have written this code and now again we will run this and we will see a next figure will appear here in which we will get this. Let's run it and we will say if any error is coming. It has shown lots of warning here, don't know why. So but we can see here our the next signal which is unit step signal. It has a n equal up to 0, the values are zeros and after n equal to 0 the values are 1. So this is the unit step signal. In the similar way we will write now unit ramp sequence. Okay, now we will write unit ramp sequence. For that let's write it here, unit ramp signal, and in here we will write x2 will be another vector having the values from 0 to 5. So we know how it will create the values. It will be vector from 0, 1, 2, 3, 4, 5 and after that we have x in which we will store our values. In that we have to create zeros of 1, 5 means 1 row and 5 columns and after that we have to append the x2. I will show how it is creating the ramp signal and after that there is nothing much difference. We have to copy and paste the signal from above. So I will write here and I will paste it. So it is we can see we have to write here unit ramp and we have to change the subplot. We have not written here. After x it will be here sub subplot and in the subplot we will write n comma x. No, sorry, not n comma x. It will be 2 comma 4 comma 3. This will be our subplot, means we are using the third. So third next figure will appear here. So we will run it, but before running we will see how it will create ramp function. So let's go to the board again. So in the next what we are doing, here we have written x2 equal to, let's write from black, x2 equal to 0, 5. What this means? It means we are creating 0, 1, 2, 3, 4 and 5. After that we are creating the x. How we are creating x? X has been created from, first we create zeros from zeros vector and then we write x2. What it will contain? We have to see. It will contain 5 zeros first. First of all, it will contain 5 zeros, and after that it will contain these values 0, after 0, 1, 2, 3, 4 and 5. So this 0 is standing at n equal to minus 5, this 0 is standing at n equal to minus 1, this 0 is standing at n equal to 0, and this 5 is standing at n equal to 5. So I can draw the signal like this. I can draw the signal like this. We have 5 points 1, 2, 3, 4 and 5. Here also 5 point 1, 2, 3, 4 and 5. Now we will, here we will also show 5 points 1, 2, 3, 4 and 5. Now we will draw our signal. We have 0, 0 till n equal to minus 1. Till n equal to minus 1 we have 0. After n equal to minus 1, at n equal to 0 again we have 0, but after at n equal to 1 we have 1. So it will be like this. N equal to 2 we have this, n equal to 3 we have this, n equal to 4 this, and n equal to 5 this. Means it is like a ramp, it is increasing in nature. So that this is called the ramp signal. So we have written the code in Matlab. Now we will execute the code. We are going to execute the code unit ramp. So let's run the code. It is giving error at line number 20. So I have missed 0 here, that's why it is saying ZERO 0, ZERO, and we have written 0 here. So we have to delete zeros from here. Now it's okay. Again running. So now we can say this is our ramp signal. This was our unit step, was our unit impulse, and now we have created our unit ramp signal. So in this way we have created 3 signals, and in the next video we will create the exponential signals in this same figure window, because we have now again we can see we have just used 3 subplot. We have used just 3 subplots, and now we are left with 5 more, 4 down and 1 here. So we can draw 1 here and 5 here, 4 here. So in total we can use 5 figures. So that 5 will be filled with exponential signals, which we will draw in the next video.